Okay, friends, welcome to our webinar 5G NR frame structure and numerology. So 5G is here. The last decade had been about empowering the world through mobile broadband. It has changed the way we do everything, ranging from ordering food, getting a taxi, or to use the online courses. So now it is time for 5G. Hi friends, it is so good to see you all again. This is Gaurav Goyal. First of all, thanks a lot for joining this webinar. Instead of spending time here and there, you are here. This proves you are very serious about yourself. It means career growth means a lot to you. So again, I really appreciate from core of my heart for giving me your precious time. I will try my best to make every second of your work through this webinar. Again, this is me. My name is Gaurav Goyal. I have been in telecom industry for over 17 years, mostly in wireless industry. I have worked in telecom in one capacity or another. I have worked for all the largest telecom service provided in US like AT&T, Verizon, T-Mobile, Sprint, etc. Also with major vendors like Nokia, Ericsson, Huawei, etc. Before coming to US, I have worked in various countries like India, Nigeria, Finland, and UK as well. So much of that time has been spent in the wireless networks only. I have begun my career with 2G and now I'm working with 5G for at least last 4 years. At this moment, my focus is on 5G, cloud, computing, ORAN, etc. So, okay, friends, this is all about me. For more details about me, you can check my LinkedIn profile, which is, you can see here, and linkedin.com/in/Gaurav-Goyal.5G. So this is my LinkedIn profile. You can check that thing. So let's talk about the agenda of this meeting. So learning objective is NR frame structure and numerology. So in this webinar, we will analyze the access scheme. In 5G, there comes a new concept which was not there in the previous technology. That concept is called flexible sub-carrier spacing. In this webinar, we'll describe multiple access scheme used in case of 5G. Also, we will inspect the 5G NR numerology and the physical resources. There are many features in 5G, but I feel flexible sub-carrier spacing is the most important feature in case of 5G. In case of LTE, the majority of networks are operating in the frequency range between, if you say in LTE, they operate in the range between, you can say 700 megahertz to 2.6 gigahertz. So fixed sub-carrier spacing of 15 kilohertz in LTE is enough. But in 5G, use cases and frequency range is very wide. So if you talk about 5G, in case of 5G, our frequency range can go up to generally 52.6 gigahertz, but it can go up to 90 gigahertz as well. And there are many use cases like eMBB, URLLC, MMTC. So all these new cases were not present in case of LTE. So in case of LTE, 15 megahertz 15 kilohertz sub-carrier spacing is enough. But in case of 5G, since our frequency range is very large, they are very new use cases. So 15 kilohertz subspacing will not work in case of 5G. So in 5G, there comes a new concept which was not there in 4G or in the any kind of previous technology, which is flexible sub-carrier spacing. I think the support for multiple sub-carrier spacing is the most outstanding 5G feature when compared to LTE. Let's explore 5G frame structure and let's see what is new in it. So in this webinar, we'll cover all the topics like what is multiple access, what is NR cyclic prefix. We'll explain 5G frame structure. In addition to, we'll see the importance of numerology, why we require different kinds of numerology and these topics. So these are the topics we'll cover in this webinar. But before jumping to topic, I want to say one thing. Your involvement in the class is critical for you to benefit from this webinar. I request you, if it is not absolute necessity, then please close your Outlook, Facebook, WhatsApp, or any kind of social media if possible. It is proven fact that there is no such thing in the world which is called multitasking. There is no such thing as multitasking. Even a genius can't do two tasks at the same time. So it is my kind appeal to everybody. Please close all kind of social media or any kind of distraction. Moreover, there will be quiz and only person who is attentive can answer those questions. So also, please stay till the end because I will offer lots of bonuses and offers on my complete 5G course. So please do not do any kind of multitasking. So are you with me? So if you are with me, can you please write yes in the chat box and then we can jump to our webinar. Please write yes in the chat box. Thank you. Let's jump to the topic. (5G) frame structure and numerology. So in telecom world, spectrum is the most expensive thing to buy. This we know. Spectrum is the most expensive thing to buy and it is not unlimited, right? So for high efficiency, we must use it in the most efficient way. The most efficient way to use the spectrum is called multiple access. So what is multiple access? So multiple access is a technique through which multiple mobile users share the allocated spectrum in the most effective manner. Since the spectrum is limited, the sharing is necessary to improve the overall capacity over a geographical area. So in multiple access scheme, the available bandwidth is to be used simultaneously by different users. And in case of 5G, various kinds of access techniques are used, but most important techniques used are OFDMA. Second one is TDMA. And third one is SDMA. So in case of 5G, all these access techniques are used to have a efficient transmitter between UE and the BTS, or you can say G node B. So the first thing is, first access scheme is the OFDMA. So OFDMA is based on OFDM, which is orthogonal frequency division multiplexing. So in case of OFDMA, data is divided into smaller units called subcarriers. Or you can say, in case of OFDMA, data is delivered to end users through the use of multiple subcarriers. The benefit of OFDMA is that subcarriers do not interfere with each other. In OFDMA, users are allocated physical resource block, or you can say resource block, to transfer information, or you can say to transfer the data. So PRB is the actual physical resource that is allocated to user. So a physical resource block is the smallest provisioning unit in case of LTE or 5G. So what is PRB is made up of? So you can see here we have frequency domain. On the x-axis, we have time domain. So PRB are composed of 12 subcarriers in the frequency domain, and they are comprised of 14 symbols in case of time domain. So the lowest unit in the frequency domain is the subcarrier, and the lowest unit in the time domain is the symbol. Just remember for at this moment that in frequency domain we have subcarriers, in the time domain we have symbols, and these small boxes, these small squares, are called resource elements. So you can say that in one resource block we may have 12 into 14, we may have 168 resource elements. Okay, so just remember these small things at this moment. We'll explain it in detail in later on, but at this moment just remember the smallest unit that can be allocated to users is resource block, and in one resource block we have 12 subcarriers and 14 OFDM symbols. Next is TDMA. So TDMA is other way to divide the limited spectrum available. In TDMA, we divide each channel into different time slots. So in effect, a single frequency support multiple and simultaneous data channel. Suppose we have this data channel or any channel, and if we divide it into two slots, slot number 1 and slot number 2. So this data channel can be allocated to 2 users. So with 2 time slot TDMA, 2 users can share the same frequency. With 3 time slot TDMA, 3 users can share the same frequency, and so on. So TDMA is based on transmission to and from UE with separation in time, right? With separation in time. The third technique we have is SDMA. The full form of SDMA is space division multiple access. It is also called MIMO, which is multi-user or you can say multi-user, multiple input, multiple output. So what is multiple user, multiple input, multiple output? It means you can provision MIMO for more than one UE simultaneously. You can share the same radio sources to more than one user simultaneously. This is not a new concept. We have multi-user MIMO in current LTE as well, but the scale of multi-user MIMO will be much larger, and the development will be and the deployment will be very common in case of 5G as compared to LTE. So in 5G, the multiple access scheme for NR physical layer is a combination of three techniques. One is OFDMA, one is TDMA, and the third one is SDMA, which is also called multi-user MIMO. Okay, so these are the three techniques you should remember at this moment, that three main access schemes used in case of 5G are OFDMA, TDMA, and SDMA. So I know you must have seen this figure many times before. So this figure always helped me to explain the OFDMA. So if you think that there is large amount of GBPS data is coming, and we divide that data from serial to parallel, and then we get these small water shower, and you can say very low data rates. And these all are called subcarriers. So each of these lines are of low data rates, or you can say these subcarriers. Every subcarrier is of very low data rate, but the combination of all these subcarriers give us very large amount of throughput, or you can say large amount of data rate. So this is the biggest benefit of these subcarriers. So let me explain with the help of one diagram. So we have a carrier. You can say if we have this carrier, we have a center frequency. We have some bandwidth. We are talking about here in the frequency domain. And this bandwidth is divided into what we call subcarriers. Right? So these all are our subcarriers. So as I said earlier, that in case of LTE, the distance between two subcarriers is always fixed, that is 15 kilohertz. But in case of 5G, the distance of subcarriers can be 15 kilohertz, it can be 30 kilohertz, it can be 60 kilohertz, it can be 120 kilohertz, and so on. We'll discuss in detail. But at this moment, just remember that in case of LTE, subcarrier spacing is fixed, which is 15 kilohertz. But in case of 5G, subcarrier spacing can be 15, 30, 60, or 120. So here I want to say that we have a carrier, we have a center frequency, we have some bandwidth for this carrier, and we are talking about frequency domain. And bandwidth is divided into what we call subcarriers. So OFDMA divides a channel into small units called subcarriers. Think of it as a water shower. So by subdividing the channel, small packets can be transmitted in parallel to multiple devices simultaneously, like a parallel stream of water from the shower. And by breaking large block into smaller channels, there is a protection against fading. And due to this protection, we get better throughput and efficiency. So OFDMA method allows data to be delivered to end users through the use of multiple subcarriers, right? Multiple subcarriers. Before jumping to numerology, we have to review small things about LTE. So in case of LTE, we have bandwidth of 20 megahertz, right? And in case of LTE, our maximum number of resource blocks are 100 resource blocks, right? One resource block is equal to 12 contiguous subcarriers. So there will be total 1200 maximum subcarriers in case of LTE, right? But if we take the example of 5G, in case of 5G, the maximum bandwidth that can go is 400 megahertz, right? And according to 3GPP, maximum number of resource blocks allowed in case of 5G are 275. 275 resource blocks are allowed. So, and 1 RB is 12 contiguous subcarriers. That is same as in case of LTE. So 1 RB is equal to 12 subcarriers. So there can be maximum. In case of 5G, we have 3,300 subcarriers. So you can see we have huge increase in case of 5G as compared to LTE. So again, in case of LTE, we have 20 megahertz of bandwidth, and this bandwidth is managed by scheduler. So that is scheduler to manage. We can give 100 RBs to 100 different users or 100 RBs to one user. That is work of a scheduler. Then we get into 5G. In 5G, we have maximum 400 megahertz of bandwidth at this moment, and wider subcarrier spacing gives large amount of RBs as compared to LTE. So thus 3GPP has decided that maximum 275 RBs can be possible because it can be managed. More than these RBs can't be managed at this moment of time. So maximum RBs allowed is 275 RBs in case of 5G. Okay. Okay. Again, let's understand a little bit more about LTE and 5G before jumping to our topic, numerology. So these concepts are very important if you want to understand numerology in detail. So So we have here frequency domain, and we have here time domain. And as I said that in the frequency domains, we have subcarriers. In the time domain, we have symbol. Right? So if we talk about like this, we have symbols in the time domain and we have subcarriers. And this unit is called, this small box is called resource element. So in case of LTE, the subcarrier spacing allowed is 15 kilohertz. Okay. And in case of LTE, each PRB consists of 12 subcarriers and 7 symbols per slot. Okay. In case of NR, various kinds of subcarrier spacing is possible, like 15, 30, 60, 120, and 240. So here, instead of PRB, we use the term RB, which is resource block. And same, we have 12 subcarriers, but in one slot, we have 14 symbols. Okay, in case of 5G, in one slot, we have 14 symbols. Okay, this, just remember this thing, that in case of 5G, we have 14 symbols per slot. So again, the lowest unit in case of frequency domain is subcarriers, and the lowest unit in the time domain is symbol. And the resource element is the smallest unit that can carry the modulation symbol. So anytime we are assigning PRBs, we are assigning 12 subcarriers. For 5G, frequency domain still has 12 subcarriers, but time domain has 14 symbols. So we are saying that those concepts are not changing. We still have resources aligned in the frequency and the time domain. And the resource element is the smallest unit that can carry the modulation symbol. So this concept is not changing. But what is changing is the flexibility that will come into picture. We may have subcarrier spacing of 30, we can have subcarrier spacing of 60, 120, 240, and so on. So this diagram will bring it together. Again, let me explain it in detail. So we have here frequency domain. We are here time domain. In time domain, we have symbols. In frequency domains, we have subcarriers. Okay, and then we have resource element. So you can see like this. And this is our resource element. And modulation is assigned based on each resource element, right? And this modulation can be QPSK, it can be 16 QAM, it can be 64 QAM, it can be 256 QAM. So what is this thing? So in modulation means how many bits can be represented for one subcarriers for one symbol time. So QPSK represents how many bits? 2 bits. 16 QAM represent how many bits? 4 bits. 64 QAM 6 bits. And 256 QAM represents 8 bits. In case of LTE, only up to 64 QAM is allowed. But in case of 5G, a new modulation, which is 256 QAM, is also allowed in case of NR. And as you know that subcarrier spacing is inversely proportional to time. So if our subcarrier spacing is 15 kilohertz, then our time is equal to 66.67 microsecond. So this symbol time is 66.67 microsecond for 15 kilohertz subspacing. So if you increase the subcarrier spacing to 30 kilohertz, the symbol time will be reduced to half. That will be 33.33 microsecond. If you increase subcarrier spacing to 60 kilohertz, again it will reduce to 16 point something. So as we increase the subcarrier spacing, the symbol time will reduce. So again, here is the frequency domain and here is the time domain. The lowest unit in the frequency domain is the subcarrier, and the lowest unit in the time domain is the symbol. And I got subcarriers like this, and subcarrier spacing is inversely proportional to the time. And the name given to one subcarrier by one symbol time is the resource element. And here is where my modulation symbol goes. It could be QPSK, 16 QAM, 64 QAM, and 256 QAM. And when I send data over the air, I take all these modulated symbols and combine them into what is called OFDM symbol. So it is like playing all chords of piano together. Some chords are high frequency, some chords are low frequency. So like playing all the chords of piano together. Okay. So this is the high level concept of subcarriers, symbol time, and the OFDM signal. Okay. Let's jump to next slide. Next, we have to understand what is cyclic prefix. To understand numerology, cyclic prefix is also one of the most important concepts. Let's understand cyclic prefix. In the meanwhile, let me check the chat. Okay, so then we have this cyclic prefix. So there are some beautiful questions asked by some people. I will answer those questions in detail, maybe at the end of this webinar. But questions are very beautiful. Please keep on asking these good questions. But let me check one or two questions. So the one, if comparing the same bandwidth, it will be same RBs? Yes. So the question comes, if LTE and NR, if we are comparing that they have same bandwidth, suppose 20 megahertz, here also 20 megahertz, then number of resource blocks will be same. Yes, in that case, number of resource blocks will be same. Okay. Yes. So this was question asked by my friend Resfiando. Yes, number of resource block will be same. Then the question asks, what kind of modulation is used according to 3GPP? So as I said earlier, that in case of 5G, we can use modulation QPSK, 16 QAM, 64 QAM, and 256 QAM. Okay, so these kind of modulation we can use according to 3GPP in case of 5G. Okay. So there are many other questions, but let me jump to the topic first, and then we may answer those questions in the end. Okay, friends. So we were talking about cyclic prefix. So suppose we have one transmitter, and suppose we have one receiver. So between transmitter and receiver, signals can reach in many ways. It can go through the direct path, which is maybe you can say path number 1. It can go up to some other path. Maybe there are some mountains here, right? Some mountains, and it can reflect through the mountains, and which can be path 2. Or it can, there may be some buildings here, and it can reflect through the buildings, and it can come through path 3. Okay, so first symbol come like this, right? So first symbol is the red. So first symbol may come like this, right? And the second symbol may come like this, right? But the second symbol and first symbol may interfere with each other, and this can rise to what you call inter-symbol interference. And any kind of interference should be avoided in case of telecom, because it can affect our KPIs. It will reduce, it will degrade our KPIs. Any KPIs, it may related to accessibility, it may related to retainability, it may related to throughput. So we should avoid any kind of inter-symbol interference. But what will happen if there is a wait time of few seconds or few milliseconds between these two symbols? If there is a wait time between these two symbols, then these two symbols will not interfere with each other, and we can overcome what is called multipath inter-symbol interference. So cyclic prefix helps us to overcome multipath inter-symbol interference, right? So again, so you can get direct signals and you can get deflection of some signal. So I sent out a signal, and on the receive side, you get a direct signal and a reflected copy of all these signals from a multipath. So if I send a new signal and if I look at the multipath, it is interfering with my next signal. But think what will happen if the next signal comes after some delay. So if there is some wait time between two symbols, then there are less chances of interference. So this wait time or guard time is also called what you call as a I'm not able to write. What do you call as a cyclic prefix? So system wait for CP amount of time to send the next signal. So if I have copies, then we can send next OFDM symbol later on. So this concept is called cyclic prefix. So this concept is very important in case of numerology. So again, with the help of this slide, we can understand cyclic prefix. So in the transmitter, the OFDM symbol is extended with the help of this cyclic prefix. The purpose of cyclic prefix is to avoid what you call inter-symbol interference. In simple words, avoiding interference between successive OFDM symbols. So the question comes, how the CP is constructed? So the CP is constructed by taking the end part of output waveform and copying it in the front of waveform. Okay, so suppose our symbol time is 66.67 microseconds. Okay, so cyclic prefix is generally 6.6% of the total symbol time. So the cyclic prefix will be around 4.69 microseconds. In case of LTE, we have in one symbol, we have 2048 samples. And the 7% of this is around what you call 144 samples. So 144 samples are used for cyclic prefix. Okay, or you can say 6.6% of 66.7 microsecond is used for cyclic prefix. Due to this, our symbol time increased to 66.7 plus 4.7. It increased to 71.4 microsecond. This 4.7 microsecond is completely wastage, but it is required because we have to avoid the inter-symbol interference. So again, one thing to note here is that this cyclic prefix part of the OFDM symbol will not be utilized for any processing in the receiver. It is just an overhead. It is just a waste and it simply be discarded. And let's understand CP with the similar example we have just discussed. So let's consider this multipath. So here you can see we have three paths. Path number 1. We have path number 1. We have path number 2. We have path number 3. So you can see path 1, this is the direct propagation path through the base station and the mobile device. Path number 2 with a small delay and it is coming through trees and or you can say reflected through trees. A third part with the largest delay and it is reflected through the building. So the replicas of transmitted signals are received with different delays at the receiver. It caused the multipath delay spread of the radio channel. So the cyclic prefix should be designed such that it is always longer than the multipath delay spread. So why cyclic prefix should be longer than the multipath delay? Because our main purpose is to avoid the inter-symbol interference between the successive OFDM symbols, and it can be avoided only if symbols do not interfere, which can be achieved by larger CP. So in our example, cyclic prefix is too short so that there will be some kind of inter-symbol interference. So what we can conclude about CP, the higher the CP, the more useful it is to eliminate the ISI, but also higher the full time of symbol, it takes longer to transfer the same information. And one thing here is to notice that cyclic prefix is dependent on the subcarrier spacing. So as I said, in case of 5G, we may have different kind of subcarrier spacing. It can be 15 kilohertz, 30, 60, 120. We'll talk in detail in later slides. But in case of 15 kilohertz, our subcarrier, our cyclic prefix is around 4.69 microsecond, or you can say 4.7 microsecond. In case of 30, it will be reduced to half. That will be 2.35 microsecond. In case of 60 megahertz, 60 kilohertz, it will reduce to again half. What do you call 1.17, and again half, right? So cyclic prefix will also reduce as we increase the subcarrier spacing. So again, at this moment, just remember, larger the subcarrier spacing, shorter will be the cyclic prefix. So CP is a sample that is copied and pasted to the end of each transmitted symbol to its beginning. So it functions as a guard interval, and it allows to eliminate the inter-symbol interference practically without additional hardware use, right? So this is the cyclic prefix. Okay. So again, in case of 5G, we have a frame which is a frame size is of 10 millisecond. Okay, and each frame is divided into this is frame divided into smaller subframes. So it is divided into 10 subframes. These are the subframes, and the length of each subframe is 1 millisecond. So in case of 15 kilohertz, when we have subcarrier spacing of 15 kilohertz, we have one slot, and in each slot we have how many symbols? We have 14 OFDM symbols. We have 14 OFDM symbols. Out of these, first 3 symbols are used for signaling, or you can say PDCCH channel, and rest of the 11 symbols from 4 to 14 is used for data transfer. Okay, so this is same as LTE. Okay, but what happens if I decided to deploy subcarrier spacing of, you can say, 30 kilohertz? Okay, and here just remember, there is one thing called TTI. TTI here is 1 millisecond. Okay, so TTI here is 1 millisecond. So if I want to deploy a subcarrier spacing of 30 kilohertz, then in that case, one subframe is divided into 2 slots, slots number 1 and slot number 2. And again, slot number 1 will have 14 OFDM symbols. Slot number 2 will also have 14 OFDM symbols. So in case of 30 kilohertz, there will be 28 symbols in one slot. Okay, and our TTI will reduce to 0.5 millisecond. Okay, so This is good for 15 kilohertz. But what if I decided to deploy 30 kilohertz spacing? So if there are 14 symbols in 1 millisecond in 15 kilohertz spacing, so what will happen to symbol time if I double the subcarrier spacing? So symbol time will reduce to half. Why this is important? Because we know what is TTI. TTI is how often the scheduler can make decision. So if a scheduler can make, maybe you can say 100 decisions here in 1 second, in case of 30 kilohertz, a scheduler can make 200 decisions, right? So there will be doubling of decisions. So, but what will happen if my subcarrier spacing increase to 60 kilohertz? Can you answer in the chat box? What will be my TTI if my subcarrier spacing is increased to 60 kilohertz? Can you please answer that in the chat box? And in the meanwhile, I will take a deeper sip of water. Very nice. Everybody has given the right answer. So it will be 0.25 millisecond. Okay. So it will be 0.25 millisecond. So this shows, guys, you are listening it very carefully. Thanks a lot for listening. So again, what we have learned so far, we have learned that the physical layer employs OFDM, which is orthogonal frequency division multiplexing in the downlink. And OFDM divides large amount of data into smaller units called the, what you call, subcarriers. And these carriers can be 15 kilohertz wide, 30 kilohertz wide, 60, 120, and so on. And each subcarrier can be modulated using QPSK, 16 QAM, 64 QAM, or 256 QAM, as permitted by the radio conditions. So in OFDMA, users are allocated what you call the source block. And the source blocks are comprised of 12 subcarriers per slot and 14 symbols on the time domain. Long story, in OFDMA, each subcarrier carries a small amount of data, and the multiple subcarriers together help achieve a very high data rate. Okay, guys. So let's jump to our topic, which is numerology. So all these topics which we have discussed till now are very important as a base for numerologies. Okay. So if you have any question, please let me know in the chat box and I will try to answer those questions. Okay, so no questions. It means you are understanding what I'm saying. Okay, so let's jump to our numerology part. Okay, to understand numerology, let's draw a figure. So first of all, we should know what is numerology. So numerology is basically a set of parameters for the 5G physical layer that are dependent on subcarrier spacing. Okay, so let's talk about numerology. So if I divide into maybe 4 lines. So here you can write the numerology index. Here you can write the subcarrier spacing. Here you can write the slots per subframe. Here you can write the TTI, default TTI, right? And here you can write the cyclic prefix. So all these parameters are affected by the numerology. There can be many numerologies supported in case of 5G, but generally we talk about 4 numerology, which is 0, 1, 2, and 3. Okay, we generally talk about these 4 numerology. In case of numerology 0, what will be our subcarrier spacing? It will be 15 kilohertz. What about 1? We have 30 kilohertz. What about 2? We have 60 kilohertz. And what about 3? We have 120 kilohertz. Okay. So how many slots per frame? As we have discussed, there may be 1 slot in case of numerology 0. In case of numerology 1, we may have 2 slots per subframe. In case of numerology 2, we have 4 slots per subframe. And in case of numerology 3, we have 8 slots per subframe. And this can also be calculated with the help of this, like 2 raised power mu into 15 kilohertz. And this is also called mu. So if mu is 0, our subcarrier spacing is 15. If it is 1, 30, 2 is 60, and 3 is 120. And what will be a TTI? So TTI will be here 1 millisecond, here 0.5 millisecond, here 0.25 millisecond, and here 0.125 millisecond. So lower latency over the here. And cyclic prefix, as we discussed, in case of 15 kilohertz, our cyclic prefix will be 4.67 microsecond. And here it will be, if you divide around 2.39 microsecond, then we will have 1.17 microsecond. And then we may have 0.58 microsecond. So cyclic prefix size will also reduce, right? So it works out like this. The whole point is that the faster I can make scheduling decisions, the lower the latency is. So this thing is coming very fast. We thought LT is fast. So if in LT, suppose we can make 1,000 decisions per second. But in case of LT, when we have subcarrier spacing of 120 kilohertz, we can make 8,000 decisions per second. Is it crazy fast? Yes. This is how quickly we send these things over the air interface. Okay. But the only thing we have to note here is that these numerologies are assigned according to the frequencies. We'll discuss in Doppler effect in next 3-4 slides. But just remember, when the frequency is low, then we can assign numerology 0, 1, and 2. And when the numerology is 2 and 3, we can assign FR2. So details of FR1 and FR2 you can see in my 5G course. But in low frequencies, you can assign numerology 0, 1, and 2. In high frequencies, we can assign numerologies 2 and 3. Okay. Let's see one thing. Okay, so these are the supported numerologies in case of 5G. Sorry. Just 1 second. Okay, so these are the numerologies that is supported in case of 5G between 0 to 4. Again, what is numerology? So numerology is a set of parameters that is dependent on the subcarrier spacing. That is dependent on the subcarrier spacing, which can be 15, 30, 60, 120, or 240. So numerology is effectively an indication of the subcarrier spacing. Currently in 5G, you can have numerology from 0 to 4. But just don't give too much importance to subcarrier spacing 4, because this subcarrier spacing is used for only sync channels like PSS, SSS, or PBCH. So no data is transmitted on this numerology number 4. So here we are talking about creating what is called the physical resource block, or you can say PRB. So same terminology we use in 4G, but it is slightly different here. So this is the frequency domain, and that physical resource will have 12 subcarriers. So numerology 0. So here we have numerology 0. So here we have numerology 0. So here it is equate to 180 kilohertz. So one resource block is 180 kilohertz. So what will happen when we change the numerology from 0 to 1? Okay, so the subcarrier spacing doubles to 30 kilohertz. Therefore, the size of physical resource block is also going to double, but it still has 12 subcarriers. So our resource block size will increase to 360 kilohertz. When we go to numerology 2, our resource block size will increase to 720 kilohertz. When we go to numerology 3, our resource block size will increase to 1440 kilohertz, and so on. Okay, so you can see the numerology has big effect on the size of these resource blocks. So you can see it is going to double each time as we go up in case of subcarrier spacing. But it is always 12 subcarriers, but the actual size in terms of kilohertz is going to vary drastically depending on the numerology. So earlier we have 180 kilohertz, then we have 360, then we have 720, then we have 1440, and so on. So now it is worth noting that you don't just randomly pick which numerology you want. So you will find the numerology is very linked to the frequency band that you deploy on. So if you deploy lower frequencies, then numerology 0, 1, 2 are the good candidate, FR1. If you deploy millimeter wave, then higher numerologies like numerology 4 and 2 are the good candidate. Okay. So this is the numerology from 0 to 4. So that is what I was talking about earlier. So here you can say we have frequencies up to, you can say, less than 1 gigahertz. Here you can say frequency less than 7 gigahertz. This 6 is wrong. It should be 7. So earlier it was 6 gigahertz in case of 5G, but now they have increased FR1 to up to 7 gigahertz. And then we have higher frequencies. It can be between 24.2 gigahertz to, we'll discuss in detail in next 3-4 slides why we require different kind of subcarrier spacing according to our frequencies, because it will affect our Doppler effect, but we'll check in next 3-4 slides. Then we have this 24.2 gigahertz to 52.6 gigahertz. Okay, so when we have very low frequency, what is a good candidate? Good candidate is subcarrier spacing of 15 kilohertz. When we have between 1 gigahertz and 7 gigahertz, then our good candidate is 30 kilohertz, right? 30 kilohertz. When our frequency range, we are in the millimeter waves, our good candidate is 60 kilohertz subcarrier spacing. And as we discussed earlier that cyclic prefix, so if symbol time is 66.67 microsecond, cyclic prefix is 6.6% of that symbol time, right? So in case of 15 kilohertz, our symbol time is 66.67 microsecond. So our cyclic prefix will be 4.7 microsecond. In case of 30 kilohertz, our cyclic prefix will be 2.4 microsecond. In case of 60 kilohertz, our cyclic prefix will be 1.2 microsecond. But the slot duration will also reduce. The slot duration is earlier 1 millisecond. Then we have this 500 microseconds, and then we have this 250 microseconds. As I said earlier, so if we can make 100 decisions in 1 millisecond, here we can make 200 decisions in 1 millisecond, and here we can make 400 decisions in 1 millisecond. But the symbols per slot will always same. It will be 14, 14, and 14. It will never change. Okay, so just remember, symbol per slot will never change. It will always remain 14, 14, 14. Okay. So guys, can you hear me? Some person is saying that he is not able. Can you write yes in the chat box if you are able to hear me, please? Okay. 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 Thank you, sir. Okay. So I think, okay. Mr. Bekurtesan, please restart your laptop because almost everybody is able to hear me. Thank you. Okay. So this is what I was talking about: orthogonal subcarrier and symbol duration. So as I said earlier that subcarrier spacing is equal to 1 by T. So why we need this thing? So when subcarrier spacing is 15 kilohertz, our symbol time is 66.7 microsecond. Okay, so why we need this equation? So we need this equation because if this equation is valid, only then we can avoid inter-symbol interference, right? So inter-symbol interference can be avoided only when symbols are orthogonal to each other. And symbols are orthogonal to each other only if this condition is valid. That is, subcarrier spacing is equal to 1 by time. So if we're able to follow this equation, then we can avoid what you call inter-symbol interference. But there is one more thing which is called the inter-carrier interference. Inter-carrier interference. That thing is also avoided if you need high accessibility, retainability, throughput, or all kinds of KPIs. So how to avoid this thing, inter-carrier interference? To avoid inter-carrier interference, this equation, Doppler shift by the subcarrier spacing, should be very, very less than 1. Let me explain it with the help of one figure. So you can see here, we have various kinds of subcarrier spacing supported in case of 5G. It can be 15, it can be 30, it can be 60, 120, and so on. So what is Doppler shift? As you know, Doppler shift is the change in the frequency wave in relation to the person who is moving. And what the equation for Doppler shift is? Frequency is equal to speed of light plus speed of receiver divided by speed of light plus speed of transmitter into F0. So this is fixed, speed of light is fixed. Speed of receiver is fixed, and speed of transmitter is fixed, and that is, transmitter is never moving, so transmitter speed is always 0. So this frequency, right? So higher this frequency, which is F0, higher is the Doppler shift. Okay, so if we go from FR1 to FR2, this Doppler shift will increase. According to calculations, at 2 gigahertz, my Doppler shift is 1 kilohertz. At 20 gigahertz, my Doppler shift is 10 kilohertz, right? And if you remember, we want that Doppler shift divided by subcarrier spacing should be very, very less than 1. Okay, so in case of 2 gigahertz, if I use 15 kilohertz, right now we're talking about 15 kilohertz, Doppler shift is 1 and our subcarrier spacing is 15, and it will come as around 0.06. So that is okay because it is very, very less than 1. But in case of 20 gigahertz, my Doppler shift is 10, and if you divide by 15, it will be around 0.6, and this is not valid because according to our equation, it should be very, very less than 1. So it can be 0.05, it can be 0.08, it should be very, very less than 1. That's why our subcarrier spacing should be very high in case of high frequency. Otherwise, there will be very high effect of Doppler shift. Because, let me explain. Suppose we have subcarrier spacing of 15, here 30, here 60, and so on. So in case of 15 and in case of 1 gigahertz, suppose our Doppler effect is just this amount, right? So out of whole small amount of symbol is affected by Doppler effect, that's fine. But in case of 20 gigahertz, a large amount of area is affected by Doppler shift, and it may not be efficient, right? So, but in case of 30 kilohertz or 60 kilohertz, you can see that this amount of area is affected by Doppler effect. So this amount is left, that is good thing. That is good amount of symbol. So in case of 60 kilohertz or more, we can use higher frequencies. But in case of, if you have subcarrier spacing 15, 30, and so on, our lower frequencies is more feasible, right? So guys, any question related to Doppler effect, please let me know. Then we can jump to next topic. Okay, somebody asked me that, can you please explain the equation again? So basically, what is Doppler effect? So what is Doppler effect? So Doppler effect is the change in frequency of a wave in relation to moving observer. Suppose there are two persons, right? There are two persons, and one person is standing at one position, and other person is standing here, right? And he's speaking at some frequency or some pitch. If he's moving towards this person A, right? Even if he's speaking at the same frequency, as he moves towards this person, he seems that person A will think that he's speaking loudly. At this point, he may speak very slow, but as he moves towards the person A, he will think that he is speaking loudly. So this is called the Doppler effect. How much loud you are speaking as we move towards the user. Same thing with the frequency. As we move or as we move away from the transmitter, there is a Doppler effect. There is a change in the frequency as compared to the observer moving towards the or away from the transmitter. So the frequency is, so the equation is the Doppler change or Doppler frequency. You can say here Doppler frequency is equal to C plus VR, C plus Vs into F naught. So F naught is the frequency which we are using, right? Or you can say that frequency of operation. and this is the speed of receiver, which is always moving, like we are always moving. This is the speed of transmitter, and this is the speed of light. So whatever the answer of this equation, so that is our Doppler effect. Okay, so this is the Doppler effect frequency. So have I answered your question? Okay, thank you. So let's jump to the next topic. So inter-carrier interference can be avoided only if Doppler shift divided by subcarrier spacing is less than 1. Okay, so the wider subcarrier spacing, helps overcome the Doppler shift. Okay, so this is the main important topic, right? So this is what we have understand till now, that we have various kinds of numerologies. In case of 5G, it can be 0, it can be 1, it can be 2, it can be 3, and number of symbols per slot is always 14. Only numerology number 2 is the exceptional, that in case of numerology number 2, we can have normal cyclic prefix as well as extended cyclic prefix. So just remember, numerology 2 is always exception. So in case of numerology 2, we can have 12 symbols per slot and we can have 14 symbols per slot. Okay. Otherwise, all the numerologies always have 14 symbols per slots. And how many slots per frame? It will be 10 for 15 kilohertz, 20 for 30, and so on, right? And how many slots per subframe? It will be 1 for 15 kilohertz. It will be 2 for 30 kilohertz, 4, and so on, right? And again, our TTI, our transit time interval, will change according to our subcarrier spacing. So when our subcarrier spacing is 15 kilohertz, our TTI is 1 millisecond per slot. When 30, it will be 0.5 millisecond. When 60, it will be 0.25, and when 120, it will be 0.125 milliseconds. Okay. So this is the other way of presenting the frame structure. Again, we have one frame that is of 10 millisecond. And each subframe and each frame has 10 subframes. And each subframe may have 1 slot, it may have 2 slots, it may have 4 slots, it may have 8 slots. So we may have 20 slots in per subframe, we may have 20 slots per subframe, and we may have 40 slots per frame. Okay, and TTI is reducing according to the subcarrier spacing. So as we go down, our TTI is also reducing. So here we have these slots visualization. So what we are saying here, that in a slot we have 14 symbols, that is our normal cyclic prefix. So what I have tried to visualize here is numerology 0 and subcarrier spacing 15 kilohertz. You can see symbols are very narrow in the frequency domain. So this is our frequency domain. So symbols are very narrow in the frequency domain, but they are quite long in the time domain. So as you go to numerology 1, 30 kilohertz, the green one, there you can see we have gone bigger in the frequency domain. Our frequency domain has increased, but our time domain has reduced, right? Our time domain has reduced. When you go to 60 kilohertz, again, our frequency domain has increased, but our time domain is reduced. So, okay, so you can see here what we are playing around with the frequency and the time components of a symbol. Now it does look like you're getting more symbols, but you are using more frequency. Thereby, by definition, it is a trade-off. So you are now actually getting more symbols per second as you move through these different options. So here in 15 kilohertz, we have 14 symbols. Here we have 28 symbols per 1 millisecond. Here we have 56 and so on. So symbol time will be reduced to half. As I said earlier, why this is important? This is important because of TTI, which is transmission time interval. So TTI means how often the scheduler make decisions. So decision time of scheduler is reduced to 0.5 milliseconds when we move from 15 to 30 kilohertz subcarrier spacing. So what will happen if subcarrier spacing increase to 120 kilohertz? We will make scheduling decision 8 times fast as compared to earlier. So the whole point is that faster I can make scheduling decisions, the lower the latency is. As I said earlier, this thing is coming fast, and we thought LT is fast, but this thing is very fast as compared to LT. Okay, guys. So any questions so far? If you don't have any questions, let's have a small quiz just to see that you are getting the point what I'm saying, and then we can jump to our next topics. Okay, so let's have this question, and please answer this question in the chat box. So the question number 1 is, which of the subcarrier spacing is supported in case of NR? Can you please answer this question? There may be more than one option correct. Yes. So most of the people has given the right answer. So it will be 15 kilohertz. It will be 30 kilohertz. It's 60 kilohertz and 120 kilohertz. Okay. Thanks, guys, for giving the right answer. It means you are listening it very carefully. And the second question is, how many slots are there in each NR subframe? Yes. So everybody has given the right answer. Thank you. So answer will be D. And do you know how many OFDM symbols in one slot? Okay, great. Guys, seriously, thanks a lot for listening it carefully and giving the right answer. It means a lot to me. Okay. And then with subcarrier spacing has a normal cyclic prefix and the extended cyclic prefix. Nice. Okay. So here we don't have multiple choices, but you have to write. So as you know that we have various numerologies in case of 5G 0, 1, 2, 3, 4. Can you please tell me what's the subcarrier spacing in case of 0, 1, 2, 3, and 4? Very nice, very nice. So you have given the right answer. Okay. Can you please let me know number of OFDM symbols per slot? Very nice. Yeah, it will be always 14 symbols per slot. What about TTI? Awesome, awesome. Everybody is giving the right answer. It will be 1 millisecond in case of 0, and in case of 4, it will be 0.0625. It will increase a lot. Thank you. What about number of slots per subframe? Correct, correct. Thank you guys for giving the right answer. Number of slots per subframe will be 1, 2, 4, 18, 8, and 60. And what about number of slots per frame? So most of the people have given the right answer. So please give a pat on your back that you are listening it very carefully. Thank you. So before jumping to other concepts of 5G numerology, let's talk about this 5G course. So let me give this link. To you in the chat box. Oh, these are the topics I will cover in my 5G training. So these are all there in this. These are all topics that are covered in the 5G training, and I have given you the link for my 5G complete training. So this will be my first module. It will be 5G motivation. So here we will see why we require 5G. So why 4G is not enough. In this, we'll discuss some practical 5G use cases. Also, we'll see studies done by various companies and the practical aspects of 5G. Next, we'll talk about 5G technology components. Here, we'll go through 5G new components. As you know that in case of 5G, there are various new concepts like FR1, FR2, concepts related to beamforming, network slicing, dual connectivity, cloud optimized architecture. So this concept also we will discuss in the 5G training. And then we have this timelines for 5G standards and the rollout. So in this, we'll talk about when is 5G standardized and how wireless evolves from 1G to 5G. To know the basic features of previous technology is absolute necessity. Only after going through these features, we can relate with 5G. And only then we can establish the motivation behind 5G. So this is the only way to know what are the features required in future, or you can say what are the features missing in the previous technologies. So all these topics will be covered in case of timeline for 5G standard and rollout module. Then next module will be the 5G performance and requirements. So in this, we'll dissect the requirements which should be fulfilled to call any system as 5G. We'll also explore the gap between 4G and 5G. Or you can say what are the enhancements in 5G as compared to 4G. So here we'll discuss what are the 5G promises, what are the parameters related to high data rates, parameters related to low latency, and all these things will be discussed in this module. After that, we'll discuss 5G use cases. Here we'll see what are the diverse requirements for each use case. So we'll explore what are the steps or things needed to fulfill those requirements. We'll go through various examples to understand each of these cases in a better way. We'll see how can we achieve higher data rate, how we can achieve lower latency, how we can achieve higher connection density, why this is not possible in case of LT. So these are the things people generally ask in case of interviews, that how you achieve higher data rate, what new things you do in case of LT, right? In case of 5G. So these things are asked. Then we'll talk about 5G spectrum. So as I said earlier, spectrum is the key asset for mobile operators. The available spectrum is a major factor in defining how much capacity and how wide a coverage the mobile network can provide. And as I said, 5G is the first ever mobile radio system that is designed to operate between 400 megahertz to 90 gigahertz. And here is the concept of FR1 and FR2 in case of 5G. So this is a major plus point for 5G as compared to previous technologies, which has limited spectrum options. So in this part, we'll discuss the different spectrum options for 5G, their characteristics for 5G deployment, and many other new concepts will be discussed, and all these concepts are here. After that, we'll discuss in detail the access scheme. Here we have discussed very less about 5G numerology, very briefly, but in this module, you will see various new concepts related to 5G frame structure. After that, we'll discuss the 5G deployment options. So in 5G, there are two deployment options. One is NSA and one is SA. As NSA means non-standalone mode and SA means stand-alone mode. So there is nothing called NSA in any of the previous technologies, neither in 4G, neither 3G, 2G. No such things are there in the previous technologies. So how to deploy NSA, this we can learn in this module, which is 5G deployment options. So it never happens before that two generations working together. For example, in case of LT, it is end-to-end for UE to E node B to ME, but not anymore in case of 5G. So here we'll see various deployment options in case of 5G. Then we'll discuss 5G network architecture. 5G network architecture is completely different as compared to 4G or any of the previous technologies. It uses many new concepts like SDN, NFB, and cloud computing. And it has various new nodes like AMF, SMF, UDM, PCF. So all these things will be discussed in this chapter. After that, in the training, you will also see the model tuning. We'll go through the model tuning. In 5G, we have vast range of frequencies. So model tuning is also very different in case of 5G. So in this module, we'll discuss model tuning and how to perform model tuning for 5G. And here I will explain complete atoll, how to use atoll to do the model tuning. And the last module, we will discuss the network slicing. So network slicing is very much required in case of 5G because there are various new scenarios in case of 5G like EMBB, URLLC, and MMTC. So it was not present in any of the previous technologies. So since 5G supports many use cases, so it needs something new to support all these use cases. And that use case is called network slicing. And in this module, all these things will be explained in detail. So all these things will be you get in my training part. So training is around 10 hours. And let me show you the training. Just 1 second. Let me open the training. So you can see that it has all the modules like 5G motivation, 5G technology components, which I have discussed. So you have around 11 modules in this whole training, and you will get downloadable material. If you don't want to go to videos, so with every training, I put some downloadable material. So if you go to, for example, anything like 5G spectrum, and if you go here, you will see here the downloadable material, and you can read that material just to go quickly, right? So you can just go here and just use this download material, and it's 19 pages summary. You can read this to get the essence of this chapter. And in addition to that, I have shared books more than $500 in this course. So you can see here. So all these books are shared with this training. So you can see I have shared this book, which is called 5G Physical Layer. The cost of this book is around this. And then I have shared this book, 5G NR Next Generation. This book is also shared. This book is also shared. This book is my favorite book. So 5G technology, all these books are shared with this complete course. All these books, books are more than $500. All these books are shared. If you go to this 5G training, you can see here, suppose I go to 5G technology components, you can see one book is shared. You can see here with every document. So you can see 5G technology components, 5G system design, and you click here, the book will be there, right? Complete downloadable book will be there. And if I go to some other chapter like NR frame structure, right? There will be book which I use to make this chapter, and you can see 5G physical layer. So all these 7-8 books will be available to you in this complete course, okay? And you have lifetime access for this course. In addition to that, 100% satisfaction guaranteed. Otherwise, I will refund your money, okay? And you can see this course is very low as compared to other courses. So if you go to any reputed companies like Award Solution, right, which is very good company. So, but their courses are very expensive. So you can see here. You can see here for a small course, they are charging around $95 per hour. Only 1 hour, that is self-paced, $95. If I go to some other companies, you can see This is also good company, APS Training. They are charging around $105 for the course. So same thing, I have given details in the PPT. So my course, I have done all these trainings and I have taken the best part out of this whole trainings, and I have shown you the which is the best thing possible that can be useful for all my students, right? So these are the things, and the course is, in addition to that, I have also given you the around 150 5G interview questions with answers that will be very useful in case you do the interviews for 5G, right? Actually, in future, I'm going to launch a new course that is which has all these topics like Kubernetes, ORAN, and NR. So that course will be expensive. That course will be around $500. But to get your trust, I'm selling this course for just $49, and all those 11 modules, 12 plus hours, and all the downloadable material will be there for you. And I'm sure that 100% satisfaction is granted along with this course. 100% satisfaction. This is my guarantee. If you are not happy, you can refund this course within 6 months. No company will give you guarantee of the 6 months. First of all, there is no refund policy in mostly any of the company. And if there is any possibility, 1 or 2 companies, they give you refund policy just for 1 month. But here, I can give you satisfaction for 6 months. Okay. So this is all about the 5G course, and I hope all of you will buy this course. But let's recall what we discussed in the 5G frame structure. And again, the link of the 5G training course is given in the chat box. I hope. So yeah, so PayPal is the only method we are accepting right now because it is very safe and it is very easy to refund money in case of PayPal. But if you just enter your email address in PayPal, then there are various options, like you can use any credit card with the help of PayPal. You just have to use. Yes, if you do the course, you will get the certificate for this course as well. That the moment you pass your exam, you will get this. Okay. Okay. Yeah. So you can use any bank account, you can use credit card, you can use debit card, anything you use to pay through the PayPal. So PayPal is very easy to pay. So if I go here, just let me show you. We go to this course. You can say, just click here. It will go you. So if you don't have account for PayPal, you don't have to make the account. It says, but you don't have to make. So suppose I will put anything like, then you will put any first name. So just pay with PayPal. If you don't have, just use here, pay with debit or credit card. Okay, just use this option, pay with debit or credit card, and just enter your email, any email, whatever you have, and just use this continue to payment. Continue as a guest, and just give your credit card details and payment will be done. Okay, so you do not need any PayPal account for this payment. Okay, you just need your this thing. Okay, so let's recall what we have discussed in case of 5G NR numerology. Just 1 second. Okay, so what we had discussed in this training, that in case of 5G, we have one radio frame that is of 10 milliseconds, right? We have one frame of 10 milliseconds, and each frame we have 10 subframes, right? In each have 10 subframes. And in each subframe, we may have one slot, we may have two slots, we may have four slots, we may have 8 slots, and so on. So we may have one slot when we have mu is 0, and when we have subcarrier spacing of 15 kilohertz. When we have mu is equal to 1, our subcarrier spacing is 30 kilohertz, and in that case, we have 2 slots per subframe. And when mu is 2, we have subcarrier spacing of 30 kilohertz, 60 kilohertz, and we have 4 slots per subframe. And then 120, we have 8 slots per subframe, and 240, we have 16 slots per subframe, right? So here we have discussed that we have various subcarrier spacing allowed, which is 15, 30, 60, 120, and 240. Okay, so and TTI will reduce from 1 millisecond to 0.5 millisecond to 0.25 millisecond to 0.125 millisecond and 0.0625 milliseconds. Okay, so TTI means how often a scheduler can make the decisions, right? How often scheduler can make decision, and lower the TTI, more the decisions scheduler can make, right? So these are the 5G numerology parameters. We have discussed in the training. So first of all, we have subcarrier spacing. So subcarrier spacing can be 15 kilohertz, it can be 30 kilohertz, it can be 60 or 120, right? So you can see here, in case of 60 kilohertz, it can be normal cyclic prefix or ECP, means extended cyclic prefix. Okay, so subcarrier spacing can be 15, 30, 60, and 120, and slot duration can be 1 millisecond, 0.5 millisecond, 0.25 millisecond, and so on, right? And slot size will be reduced as we move from subcarrier spacing 15 to 120. It will be 15 here and 120 here. What about OFDM duration? It will reduce as we move from 15 to 120. So earlier it was 66.67 microsecond, and as we move from 66.67 microsecond to 120 kilohertz, it will be 8.33 microsecond. What about cyclic prefix size? It will be also reduced to half as we move from 15 to 30. Earlier it was 4.69, then it will reduce to 2.34, then it will reduce to 1.17, and then it will reduce to 0.59. So numerology 2 is the exception where ECP is used, which is extended cyclic prefix, and here our cyclic prefix size will be 4.17 microsecond. And total symbol time will also increase because of this cyclic prefix. So earlier my symbol time is 66.67 microsecond, my cyclic prefix is 4.69 microsecond, and if you total them, it will be 71.35 microsecond. Same thing with 30 kilohertz, same thing with 60 kilohertz, and same thing with the 120 kilohertz, right? So this is all we have discussed here. And so in summary, we can say that we have identified 5G new radio numerologies from 0 to 4. We look at the frame structure and how that might change with each numerologies. how it influences the slot size or the length of the slot as well. We have seen the makeup of the frame, and we have identified, yes, you choose your band, that band will have knock-on effect to the numerology, that numerology will have knock-on effect to your frame structure. In the frame structure, you will have so many slots based on the numerologies, higher numerologies, more slots. And we identified that whole of the air interface is based on timings. And we have identified how the scheduling time changes as we move from numerology 0 to 4. So part of discussion of numerologies, we have identified that we have cyclic prefixes. Again, size of cyclic prefix depends on the value of mu, and higher the mu, smaller the size of CP. And based on that, the numerology and the size of the cell and the frequency of all these things relate. So numerology, size of the cell, frequency, size of cyclic prefix, all are interrelated. So it's all about what we have discussed is about frame, subframe, slots, and symbols. Again, guys, this is me. My name is Gaurav, and I have about 17 years of experience in telecom industries. You can get more details about me on the LinkedIn also. Please follow me on the LinkedIn. And this is my all the experience. I have worked on Sprint, I have worked in Verizon, Amdocs, all these companies I have worked in the past. So guys, thanks a lot for attending this training. I hope you will join, you will buy my 5G complete training. And that training, I think, is the best training in the market because I have done all the training and I have given you the best material. And the plus point is that if you do not like that training, you can refund that training or you can return that training anytime within 6 months of you. In addition to that, you will get books more than $500 and you will also get certificate of that training, and that certificate is very much useful in US market. Many people knows me in US and they know the value of my 5G certificate. Trust me, not many people have knowledge of 5G at this moment. If you have knowledge of 5G, you have extra advantage as compared to other people to get promotion in your job or to get a new high paying job in case of 5G. So I request everybody to go through this complete training, and I hope you will like this training. Okay, guys, thanks a lot again for all of your time. And can you write thank you in your language according to this thing? Can you find thank you in this slide and write in the chat box? And thanks again for attending the webinar. Thank you, guys.